that leads us to getting back into the swing of things. I hope everybody had a great spring break. We're going to kind of pick up where we left off. And that was at the end of use cases. So we finished use cases, I believe. And we're going to pick up now with class diagrams. I think that's where we left off. Yeah, that's where we left off. Okay, so a couple things. Let's take a look at assignments, make sure that everybody's staying up to date with what's going on. Yeah, if you're using external sources, tutorials, videos as help in your project, just make sure you put that somewhere. Obviously, you're not going to be copying what they are doing, but if you're using it as a guide to help you figure out some stuff, that's fine to put it in. Just include it in like a README, or if you have a credits, that's fine too. Just so that we can see it. Okay, so let's talk about stuff coming up. Your second milestone, which includes both your use case diagram and your requirements document, that is due Friday. Okay. Hopefully you guys have finished that already. We've went over this in pretty big detail. So if you want a refresher on exactly what this is, go back and check out the previous videos. They're available on the modules page. That is due Friday, so make sure you get that turned in. Should be relatively straightforward. This is how it's graded. This is exactly what you need. And we've covered all of those individual items in detail. Okay. Also, your third quiz, which is also on UML and use case, that is due Friday as well. So Friday at midnight, both of those need to be done, taken. Most people have taken the quiz already. But make sure you take that as well. We're going to get into class diagrams, which is the next UML diagram that we're going to be going over. We're going to get into that today. One note about the quizzes. I know this sort of thing can be challenging when you're taking multiple choice questions, and generally don't overthink the questions. The questions are not intended to trip you up. They're intended to make sure that you understand what it is that we've been going over. If you have a serious question about the validity of one of the answers, or you really think something is wrong with one of the questions, please reach out to me. But there's a reason I dropped the lowest quiz grade. Okay, I know it can be tough if you misinterpret a question or you read it wrong or whatever. Just that's why I dropped the lowest one. I know those can be tricky, but take your time and know that the questions aren't designed to trip you up. Okay. Okay, so that's it. Any questions on what you guys have coming up with the UML or with the use case? The quiz and the milestone are due Friday, but we are going to go ahead and start going over the class diagrams today. Okay. So right here in topic 7, this is where you're going to find all the information. I will upload the videos that we are doing now that covers these. I'll upload these here so you can get quick access to them. I've done the same thing for the 2 ones that we did for use case. And this also conveniently has your next 2 assignments. So these are due after the ones that are due Friday. So at the end of this month and at the beginning of April, these 2 quizzes or these 2 assignments you do. You've got a quiz and a milestone related to class diagrams, just like you have a quiz and a milestone related to use case. And so that brings us into the topic outline, where we're going to talk about class diagrams. Okay. All right, everybody good before we start? Any questions? Everybody awake? Say something if you're sleeping. Walter's sleeping. It's okay, I'm sleeping too. What time do you guys get up? Like 8:30, right when classes start? 8:15. That's pretty good.
Normal days I wake up at 9:15.
Okay. Okay. Well, y'all are up early. Earlier than I expected. Ooh, ROTC. There you go. Get in the habit of getting up early. All right. Well, I'm glad everybody's awake, except for the people that are sleeping. I don't even know how many people are enrolled in this class. I think it's like 80. And we have how many here? 16, 17. You guys get the advantage of being able to ask whatever questions you want. So let's go through this. All right. So we've got, this is a review. So UML is a term that refers to a set of documents. It's a way of representing software and systems in a way that makes it easier for people to understand. Okay, it helps us understand the relationships between the entities in the software. It helps us understand how we can interact with it as users, and helps just get a better understanding of the software itself, and hopefully to address any problems before development begins too much. Okay, so what we looked at before, we looked at use cases, and use cases help us understand how users are going to use the software. Okay, which hence use cases, and these are different categories under which a user would do it. Okay, and so we look at the example we talked a good bit about was the teacher writing referrals, and the administrator processing those referrals. And so the way in which a teacher interacts with the system is going to be different from an administrator interacting with the system. And those are different use cases, different cases under which someone would use the system. Okay. And so use cases are the actual actions, actors are the people that are using it. And we talked about some ideas where includes and extends, where includes is a reuse of functionality, and extends is kind of like a specialized or adding on to an existing use case. And finally, the last thing in a use case diagram is the use case descriptions, which is a simple sentence that explains better what the document represents or what the diagram represents. Any questions on use cases before we get into our brand new information, which is class diagrams? Okie dokie. One second. I gotta make a note of something I need to do. Okay. So class diagrams. This is, if a use case diagram is something that you would potentially show a user. So let's say we get hired to create an app or a piece of software for some sort of company. Maybe we're creating like a point of sale system, which is a system that handles payments. So maybe it's an ice cream shop. We're selling ice cream. And well, it's too early in the morning for ice cream. Let's say we have a coffee shop. And our point of sale system is responsible for being able to place orders, calculate how much they need to pay, keep track of inventory and sales and all that sort of stuff. That's the software that we're creating. A use case diagram would be beneficial to show the people that actually own the coffee shop. And it would be important for them to understand the ways in which they can interact with the application. So they would have a cashier who would actually interact with the system by placing orders. And so they'll touch on the screen and say, okay, they're ordering coffee and a bagel or whatever it is. And they do all that, they take the money. That is one way in which they can interact with the system. Okay, and so that's important to represent in a use case diagram. Also, they would have some sort of, probably like a manager or an administrator that would interact with the system in a different way, they would need to go in and add all of the different items that that store sells. So you have like a small coffee and then a medium coffee and then a large coffee, and whatever the different options are, they need to be able to go in and add all of those, set the prices, and do all that sort of thing. And so that's a different way that they would interact with the system. And so the use case diagram is beneficial for showing the clients. A class diagram, which is what we're getting into, isn't so much for the clients. Okay, this is more on the technical side of things, where layers of abstraction would hide this from the client. They wouldn't need to know how we have this set up. This would be more for the development team. Okay, but it is important to set these up so that the members of the development team can understand how the classes interact with each other. Excuse me. So let's take a look at this. So we obviously are dealing with object-oriented programming. This entire course is based around the idea of object-oriented programming. So we're going to be using classes and objects. And so in a class diagram, we are going to be representing all of the classes that we have in the application. Okay, so here's how we represent a class. We have a rectangle, and the rectangle is divided into 3 parts. Let me get my fancy. Okay. Part number 1 is the class name. Okay, simply put the class name in the top box. Part number 2, these are your attributes, sometimes called properties, sometimes called fields, sometimes called variables. Okay, these are essentially the properties of the class. Okay, notice we have the data type affixed to the end of these, so they know exactly what they are. Okay, the third part holds all of the methods. Okay, these are the actions that the class can perform, kind of generic stuff. And it's important, not only do we have the name of the method, but we have what the method accepts as a parameter variable, and then we have what the method returns. Okay. So this one, for example, get info has no parameters passed to it, no arguments, but it does have a return type of string. Because that's how we represent a class. Questions on that? I don't know why I'm yawning. Every time I start teaching, I start yawning. Must be a lack of oxygen to my brain. Okay. If there are no questions, let's move on. Now, the idea with a class diagram is we want to show the relationship between the classes in our application. Okay, and this is important because we need to know how they interact to have a better idea of how the system works, how the application works. Okay, so let's take a look at this example right here. This is what's called a domain model. And for the sake of simplicity, notice that the third part, which is the methods, have not been included. Okay, this is just so that we can not have so many things to look at. Normally you would include them, but right now we don't have them. Okay. Another thing I'll say right now, like we saw with use case diagrams, there is a lot of subtle variation that is used with UML diagrams. And so like the style of arrow or the style of line and that sort of thing, there's a lot of different variations. So if you go look up, if you're looking up examples online, just know that you're going to see a lot of variations with how they're drawn. But the same idea is present. So let's take a look at this example. We've got a customer over here. So we have a customer class, and then these are the fields of the customer class. So you've got a customer number, name, address, and phone numbers. And then let's take a look at the next one right here, which is order. We'll look at the stuff in between in just a minute. But let's look at the classes first. Okay. So then we have an order. We have an order class. And an order class has an order ID an order date, and an amount. Okay. And then over here, we have an order item. Okay, an order item would be, and the idea here is an order contains a bunch of order items, one or more order items. And so if we are going with that same coffee shop example, someone might come in and place an order, and that order might have 2 coffees and a muffin. Okay, and so there would be 3 individual order items, but 1 order. Okay, and so the first coffee, so let's say they get a small and a large coffee. A small coffee would be an order item, a large coffee would be an order item, and the muffin would be an order item. All of those would combine to create an order. Okay, and an order item has an item ID. This is probably going to be a unique identifier for that. Quantity is how many there are, and the price is how much it costs. Okay. So, any questions on the classes before we look at the stuff in between? So let's take a look at this. What we have in between here is how the classes relate to one another. All right. The first thing that we're going to look at is the idea of multiplicity. Okay, and multiplicity, as it says, refers to the relationship between objects with regards to the quantity. Okay, so this shows how many of one item interact with how many of the other item. And when we're talking about items, I mean classes. So how many objects of one class interact with how many objects of another class. Okay, so if we look at this, the way we would read this is we would say one customer places 0 to many orders. That ... star means too many. This ... star means too many. So if it's 0 ... star, that means 0 to many. If it's 1 ... star, that would be 1 to many. Okay, or 1 or more, or 0 or more. You can read it either way. Okay, so a customer comes in, they are going to place 0 or more orders. Okay, and we know this is true. Like a customer walks into the store, a customer exists. It's possible that they don't place an order. It's possible they just sit there and use our Wi-Fi and hang out and look cool. Okay, it's also possible that they place a single order. But we know it's also possible that they place more than one order. And so we need to be able to account for that, because how we set this system up is going to largely be based on that. So if a single customer, if instead of this 0 ... star, if we had a 1 there, what that would mean is one customer places 1 order. And that would be very limiting, because if that were the case, we would, 1, force every customer to place 1 order, but also restrict them from placing any more than 1 order, which would not be good. Okay, and so that's not what we want. And so reading this diagram helps us understand how to set this up. We need to set it up in a way that allows customers to place either 0 orders or multiple orders. Okay, good so far. Okay, so multiplicity refers to the relationship in terms of quantity. Okay, it's how many of one object interact with how many of another object. That's what we see represented here with these 2 numbers. Okay. Each order consists of 1 to many order items. All right, so now let's look at this second part. So now we're looking right here. One order consists of 1 to many order items. Now, why does this not say 0 ... star? Why does it say 1? Anybody? Sorry, my mic's like right in front of the chat. Let me move the chat.
Is it because that's the only instance of that class?
Not quite. So let's go back. Let me review this one more time. Okay. We have three things: customers, orders, and order items. Okay, customers, pretty simple to understand. That's a person that walks into the store and is looking to buy something. Okay. An order is something a customer places. Okay. An order is made up of order items. And so what we have here, if we look at this, when we place an order, so like, let's say we've got our coffee shop and there's a dentist office next door. And the dentist says, hey, can somebody go over and buy coffees for everyone in the office? And they write down everything that they want. The person comes over to our coffee shop and they're going to place a single order. They place one order, but that order is made up of a bunch of individual items. There might be 2 small coffees, a muffin, a latte, and some fancy drink that nobody's heard of. Okay. And so the idea is order items are the individual items. So we have small coffee, medium coffee, large coffee. We'll have the same thing for lattes and cappuccinos and all of the other coffee drinks we can think of. All of the baked goods that we have, muffins, bagels, all of those would be their own order item, the individual items that we sell. And when an order is placed, that order is made up of individual order items. Okay. And so when we look at this again here, the numbers represent what is called multiplicity, which again refers to the relationship between objects in terms of quantity. How many of one object interacts with how many of the other object. So in this first example, one customer places 0 or more orders. Okay, let me write that over here. Where is my text? Okay. One customer places 0 or more, sometimes it's 0 to many orders. Okay, that's what the first one represents. This one over here says one order consists of one or more order items. Write that in here. One order consists of one or more, sometimes it's one to many order items. Okay, now my question was, why does this not say 0 to many? This one was 0 to many. Why is this 1 to many? And again, this is why these diagrams are important. Because as a developer, as a programmer, it's important for you to understand what the system needs to do so that you can set up your code structure accordingly. So why does this say 1 to many and not 0 to many? It's a very simple answer. Don't overthink it. Right. That's exactly right. You can't have an order that doesn't have at least one item, because then you don't have an order. It's like you walk in and say, I'd like to order nothing. Well, then you don't have an order. Okay. And so that's exactly right. That's why it's 1 to many. And so reading this diagram gives us that information. Okay. And so what we would probably do is we would probably, like if we were coding this, we would have like a list of order type, or using text would have been better. I'm sure everyone can read that really well. That's his list of order items. Okay. And so that's what That's one way that we could set that up. Okay. That's what multiplicity is. It's the numbers that show the relationship between the two things. Okay. All right. Each order consists of one to many order items, and order items makes up one order. Stone, I don't quite understand your question. You said, so 0 to 1 deals with multiple orders.
I was like sort of referring to part 1, where it says like each customer can place 0 to many 0 dot star orders, and each order is placed by one customer. I'm not sure if that's clear.
Yeah, that's right. So this 0 dot dot star means 0 or more, or 0 to many orders. Okay. And you're absolutely right. It's important to read it in both directions. Okay. So let me erase this here, and I'll show you exactly what this means. So we read this left to right and also right to left. And so we would say one customer places 0 to many orders. Okay. And then we'll read it back the same way, but now we're going to go right to left. So, or 0 to many orders are placed by one customer. Okay. We just flip it. Okay. And so an order, we're going to say one order consists of one or more order items, and one or more order items make up one order. Does that make sense?
Yeah.
Okay, good. Okay. So that is the first relationship, multiplicity. Now let's get to the second one, which is the generalization specialization, which represents inheritance. Okay. Generally speaking, we're going to use an open arrow to indicate inheritance, and that's when one class inherits or extends another. And so this is kind of a review. All of you have had experience with inheritance at this point. But if class A extends class B, okay, freeze right there. If class A extends class B, which is the parent class? Or the superclass? That's correct. Okay. Because A derives from B. A is an extension of B. B exists already. Okay. And so B would be the general class, and A would be a specialized version of B. Okay. And that's what we have represented or described here. So if A extends B, class A is said to be the specialized class, and class B is considered to be the generalized class. The further you extend something out, the more specialized it becomes. Any questions on that? Okay, so when we look at this class diagram, okay, and again, it's very similar to what we have up here, but we've got it drawn slightly different. And again, you don't have to necessarily draw it vertically like this or horizontally like this. It's generally you see them horizontal like this because it's easier to represent the multiplicity this way. And sometimes with inheritance, you'll see them stacked like this as well. But let's take a look at this. The bank account class, this would be our parent, super, or generalized class. Okay. From here, checking account extends bank account, and savings account extends bank account. And so what's important to understand here is the arrow points to the parent or the super or the generalized class. Okay, that's the way this is done. Also, when you represent inheritance in a class diagram, notice that you don't repeat the methods. Okay, these don't get repeated here. The only time you would repeat them would be as if you're going to override like deposit down here. That's the only time you would set that up like that. Okay. All right, so that's pretty simple. Use an arrow to represent, or use an open arrow to represent generalization specialism. Yes.
So I have like another question regarding like the multiplicity.
Yes.
So when like referring to multiple orders, can't we just like use the number 2 as well to refer to that instead of 1?
You could, but you would only use 2 in the event that each order, are you talking about right here?
Yeah.
Yeah, so if each order had to contain at least 2 items, then you would use 2. So you would put 2 to many. Okay, and again, it's whatever the situation is. Like if you are going to force somebody to purchase at least 2 separate items, then you're going to need to be here. And sometimes you'll see like stores won't let you use a credit card or a debit card unless your purchase is over like $5 or something like that. And so that would be a situation where you would have to represent that here. So if the order total is, $5 to a higher number, you could do it like that. But this number just represents whatever actually needs to happen in that situation. And so when somebody places an order, we want them to be able to order at least 1 item, but they could order as many as they want. And if they aren't ordering at least 1 item, then we don't really have an order anyways. And so that's why it's a 1, not a 0. But if we wanted them to order at least 2 items, then we would put a 2 there.
Okay, yeah, that makes sense.
Okay. So we looked at multiplicity as the first relationship between classes, and then we looked at inheritance as the second relationship between classes. And now we're going to look at the third relationship, which is composition, or it's referred to as whole part relationship. This is when you have something contained inside of something else. Okay, so we're going to use the diamond to show composition. And that says when one class contains an object of another class. Okay, so look at these examples. A police station contains a police officer, and a police officer is contained by a police station. Okay, and so the way this is drawn is the object that is contained puts the open diamond on the side that does the containing. Okay, so a county is contained inside of a state, and a township is contained inside of a county. We already looked at the police officer situation. A file is contained inside of a directory. And so we can read this both ways. We can also say states contain counties, counties contain townships, directories contain files. Okay. Now, the idea here is we just looked at, well, let me do this. Any questions on composition or hold apart? Any questions on this and what we just went over? Okay. So what I did is we just looked at 3 different relationships between classes. The yawns are getting me. We looked at 3 different relationships between classes, but we looked at them in an isolated manner, meaning we didn't combine them all. Normally these would all get combined together. So we would combine multiplicity, we would combine inheritance, and we would combine composition all into a single class diagram that shows all three relationships in a single diagram. I showed them individually first so that we could understand them without making things more complicated. And so here's what I want you to do. I want you to take 5 minutes and see if you can add multiplicity to the examples above. Okay, multiplicity shows the relationships in terms of quantity from one object to another. Okay, like 1 to 1, 0 to 1, 1 to many, etc. Okay, so take 5 minutes and see if you can get that done. I am going to fill up my drink. All right, let's see if we can go with this. Johnny, another minute to finish up. Very good. Okay. So let's do this. So relationship between states and counties. What did you guys put for this one? On the state side, what do we have? That's right. We've got 1. So we've got 1 here. And so states contain, or so 1 state contains how many counties? That's right. One to many. Okay. And is it possible to have zero to many? And so what we would do is, is there ever exist a state that has no counties? I don't think so. I think states need at least one county. Okay. And in fact, what you might be able to do is you might be able to say two. Because there might be a requirement for each state to have at least two counties, because otherwise you have some weird country like Australia that's both a continent and a country and something like that. So one to many is probably the best answer here, but those are things to think about. Okay. All right, so now let's come down here, counties. One county contains how many townships? Townships are like towns. We don't have townships down here in the South. More of a northern thing. They're like, these are districts, or what would we call them down here? Maybe just towns or cities, maybe. I don't know. Either way, we're going to get the same thing here. One to many townships. Okay, because a county contains a county can contain one to many townships. Okay, it's like a division of a county. So the in Mecklenburg County, there's different districts within Mecklenburg County. You've got like South Charlotte and Matthews and the university area and all those separate divisions within the county. That's the idea here. It's a division within a county. Okay, now let's talk about police station. A police station, so one police station contains how many police officers? Okay, many. How many? 0 to many, 1 to many, 2 to many, 8 to many? Okay. Does there always have to be a police officer in a police station? Is it possible there are no police officers in a police station at any point in time, ever? So these are the things you need to think about. Okay, and this is why this is important, because the answer to those questions largely dictates how you set this up in terms of code. So if you need to handle your police station being empty, or the variables that you use really matter. And so I would think it's possible for the police station to be empty. And so we would put 0 to many. You could also say, maybe we are making this program or this application for, I don't know, a particular, maybe this application keeps track of all of the police buildings in a county or something like that. Who knows? And maybe they have a rule where they can't have more than 50 police officers in a place. And so instead of 0 to many, you would put 0 to 50, which tells us that there is an upper bounds. There's a cap on how many police officers can be in there. Most of the time, it's just going to be this. But again, those are the things that you need to be thinking about. And I'm trying to show you different ways that you can represent that in the event that that happens. Okay. All right, let's look at this last one. Directory and file. So one directory contains how many files? Anybody? That's right. 0 to many. It's possible that we have an empty directory, nothing's in there. And so in that situation, we would have 0 files. But it's also possible that our directory is populated with a ton of files. So we need to represent that 0 to many or 0 or more, depending on how you read that. Okay. So this is how we are now combining some of the relationships. Okay, we are using multiplicity to represent the quantity of objects that interact with objects of the other type. And we are using composition to show that one object is contained inside of another object. Okay, meaning it is made up of another object. So part of the definition of a state includes the definition of county, and part of the definition for a county includes the definition of a township. Okay, that's how this is set up. All right, well, let's stop there for today. We have let's review, and then let's talk about what we're going to do next time. So we went over, first of all, we reviewed use cases, and the idea of use cases and when they are used and why they are important. And then we looked at class diagrams. Class diagrams show name of the class, the properties, and the methods. Okay. In our class diagram, we are going to have one of these for each of the classes that we have inside of our application. Okay, and then the purpose of a class diagram is to show how those classes relate to one another and interact with one another. And there's 3 different types of relationships that we need to show. Okay, the first is multiplicity. That's, again, the numbers. The second is inheritance, and that's generalized, specialized versions of a class. And the third is the whole part relationship or composition, and that's when you have one contained inside of another. Okay. What we're going to do next class is we are going to look at complete class diagram examples where we combine all 3 of those factors into one, all 3 of those relationships into one, and then we will kind of look at several examples of that. We'll draw up some examples of both the referral application that we looked at and also the meal maker one, just so you guys get a good idea. And you should go ahead and be thinking about how the application that you are doing needs to be represented in a class diagram sense. Okay. Last thing, I want to make sure you guys don't forget, this is a final reminder. This Friday, both your quiz and your milestone 2 are due. So make sure you get those uploaded. Okay. Let me stop share and